Hi friends, so we would like to find the support reaction of a cantilever beam. So we'll draw a cantilever beam first. So beam has got the free end as point A and the fixed end as point B. So overall span length of the beam is 6 meters. And there's a point load of 1000 newtons acting at the free end, that is point A. There's a uniformly varying load of intensity 1200 newtons per meter is acting between point C and point D. Now the distance between point A and C is given as 2 meters. Distance between point C and D is given as 3 meters, and the distance between point D and B is obviously 1 meter. So as we know that in this particular case, for a cantilever beam, there will be a force reaction coming at point B and there will be a moment reaction coming at point B. Okay, so we shall be getting a force reaction acting at point B. Okay, this I am going to call as RB, and there will be a moment reaction which will be acting in the clockwise direction because it is preventing beam to rotate anti-clockwise, right? There will be moment reaction coming at point P like this. So this is a moment reaction I am going to call MB. So we have to calculate RB and MB in this particular case. So we are going to follow the condition of static equilibrium and we'll find out the MB and RB over here. Okay, so let's do and get the value of support reactions. Okay, so we know the condition of static equilibrium, that is summation of forces acting in the vertical direction equal to 0, summation of forces acting in the horizontal direction equal to 0, and summation of moment of forces that we can call moments. You can take any point, about any point must be equal to 0 because your beam is in equilibrium condition. This condition must be obeyed. Okay, so now as you can see from here, there is no horizontal force acting on the beam, there are only vertical forces. So you can easily neglect this particular case because there is no horizontal forces. So summation of forces in the x direction, this particular condition can be avoided. It is not required in this particular situation. So we'll start with the summation of forces in the vertical direction. Okay, therefore, so we can easily write down here that by condition summation of forces in the vertical direction, y means vertical direction, this is horizontal, that is x, and this is vertical, that is y. So summation of forces in the vertical direction equal to 0. This will give you, now I'm going to consider sign convention that upward forces I'm going to take positive while all downward forces has to be negative. So before that we have to do one small adjustment over here. This is a varying load. So varying load we have to convert into a point load. So how to convert the varying load into point load? That's a very simple rule. So how to convert this into a point load? We have to consider this as a triangular kind of loading. We'll follow half into the intensity and then the length over which it is acting. So it will be half times intensity is 1200 and into the span is 3 meters. Okay, so if you multiply this 600 into 3, that is this value will be coming as 1800. So we can easily, we have converted this triangular loading or uniformly varying loading into a point load, and it will always act from base, it is going to act for the length by 3. So if it is like this, friends, so it's, so if it is a point load acting, so where it is going to act, if this length is L, this length will be, friends, L by 3, and this distance will be 2L by 3. Okay, so this way we have to write down the location of it where it is. So we can identify the location where the point load is going to act. So this 1800 Newton will be acting from 1 by 3 from this particular distance because it is 3 meter. So it will be acting somewhere here, we can say like this, and this length will be like this, and this length will be, friends, from here to here will be 1 meter. So this length will be 1 meters. Okay, so now by considering this point load which is of 1800 newtons, and by considering this point load which is 1000 Newton, we are going to calculate the support reaction and moment reaction. Okay, this is the procedure we are going to follow. So let's do it. So I'm going to take first forces in the vertical direction. So this force is downward, so it will be negative as per our sign convention, minus 1000 newtons. This is negative because it is acting downward, friends. This is negative because this is acting downward like this. Okay. Now this point load what we are considering is 1800 newtons. It is also acting downward, so it is minus 1800 newtons, friends. Okay. Now other force is this one RB, which is acting upward. So we will write down plus because it is acting upward direction. So we shall write down it as a positive because it is acting in the upward direction. So plus RB. So it is acting in the upward direction. That is sign convention we are following, and that is going to be equal to 0. So this minus 1000 and minus 1800 will bring on next side. So we'll get from here RB equals, this is going to be 2800 but positive, plus 2800 newtons. Okay. So this is the support reaction, which is a force we have got here. This is very simple, that upward force must be equal to overall downward forces. So this is going to be 1000 and this is 1800, which is downward. So 1800 plus 1000 is 2800, which is straightforward. Okay. The most important part over here is that you have to convert this uniformly varying load into point load. That's all. The remaining procedure is same. So now we'll do the second part, which is to calculate the moment MB acting at point B. So for that we'll be using by condition of summation of moments, that is moment of forces at about point B. So let's do it. What you will get from here, so if you keep the beam hinge at this particular point B, so your beam is going to rotate in the anti-clockwise direction due to this 1000 Newton. So anti-clockwise I am going to take negative sign convention. Okay, so it is minus 1000 into the distance is 6 meters. It is negative because it is going to create anti-clockwise rotation of the beam. Next, due to this point load 1800, the beam is going to rotate in the anti-clockwise direction, and the distance of this particular force from point B is, this is 1 meter, and then this is 3 minus 1, that is this is 2 meters. So 2 plus 1, 3 meters. So again minus 1800. So this is also, friends, negative because anti-clockwise rotation of beam. Now the next part is the moment MB, which is acting at point B. So that is clockwise, so it will rotate beam in the clockwise direction. So it is going to be plus MB equals 0. Now again this is positive because the beam is going to rotate in the clockwise direction due to this moment. Hopefully this is clear. This sign convention is very important. Now if I solve this, what you will get from here is, you will get MB equals, all negatives will go on right hand side. So 1000 to 6 is going to be 6000. So this will be simplified as MB, that is moment support reaction at point B, is going to be newtons meter. Okay, so very simple and straightforward. So this kind of procedure can be followed to find out moment support reaction and force support reaction for a cantilever beam. Hopefully the procedure is clearly understood. Thank you very much.